Shalom and welcome to today's episode of Habaita. I am so excited to be joined by Erez Lampert, who is the CEO of Pathkeeper Surgical here in Israel. Erez, welcome to the podcast.
Thank you, Cher. Thank you for having me. Looking forward to talk.
My pleasure. So, Erez, tell us a little bit about, first of all, your background. I see that you went to the Technion. My husband also was in med school in the Technion quite some time ago, and you have your MBA. So maybe just share a little bit about, your journey, how you started off and where you're at now.
Sure. So I started in the Israeli Air Force. I was in the academic reserve, did engineering and math in the Israeli Institute of Technology, and then
Okay.
went to serve 5.5 years, basically 6 years, in the Israeli Air Force.
Wow. Okay.
I worked in the Israeli missile range. It's called Yanat for the Hebrew speakers, where we were part of the testing crew for the Aero missiles back then and still.
Wow.
Satellite
Okay.
launches and so on. So when I talk to Americans, I'm saying it's like the mini NASA, basically. That's where all
Wow.
the
It's
all
unbelievable.
the
Unbelievable. And you were there for how many
uh,
years?
6 years, and then
Six
I
years,
went to
Erez.
work for these 6 years. Worked for the Israeli aerospace industry for a while, and then started my career in some startups.
Mm-hmm.
Did this and that, and in 2012 I joined Invisalign, the dental company.
I
And
want to do it
they
actually. Okay, that's good to know.
Yeah, so Invisalign was back then starting to really ramp up their success, and they bought an Israeli startup that did dental scanners, dental 3D cameras.
Okay.
And I was brought to manage the R&D and the product, and we developed a device called Itero Element, which was really overnight success.
What
They
is it?
The Itero team is probably the number one medical device exporter from Israel. There's almost 1,000 people
Okay,
working
wow.
from Israel on the Itero Element or the Itero dental scanner, and it's still the number one 3D intraoral scanner in the world according to market penetration. So a
Is
really
that the scanner
significant
that
success.
you go to if you're getting your wisdom teeth out and you go to get
It's
that big scan that tells you if you it does like a whole
No,
panoramic
that's the beauty of
scan?
that. It's an optical scanner instead of X-ray. So usually when you
Oh,
go to the dentist, you get an X-ray scan, and X-rays are bad for us. They
right.
create cancer in the end. So you really want to minimize the amount of X-ray scans that you get throughout your life.
Yes.
So the Invisalign scanner was first designed to create the braces, the Invisalign braces. So it creates a 3D
Yes.
model of your teeth.
Okay.
Our second generation project called 5D is also capable of doing caries detection and longitudinal analysis that also reduce the need for X-ray scanning in the dentist. Um, so really, I think the future of every technology, and it relates to Pathkeeper as well, is
Yeah.
to eliminate as much of the X-ray as possible,
Mm.
because in the end, X-ray causes cancer. There's no doubt about
Yes,
that.
for sure.
So we want to
And
minimize that.
they do try to cover you, as much as possible when you get an X-ray, but it's definitely not ideal.
Exactly.
Yeah.
So that's what developed. It's the 3D scanner. The beauty here, which interesting, is once you create digital data, even in medical, you can start building new applications, even applications that you didn't plan for. And it makes even marketing so simple. Today, when you go to an orthodontist or even a general practitioner in dentistry and they take your 3D scan, they can create a
Hmm.
model of how your smile will look like. So it's even a marketing tool. It started as a clinical tool to create a more efficient way to create the 3D model of your teeth, but it becomes a marketing tool because when it's digital, you can start edit it and you can start
Yeah.
build that capabilities and create more functionality. So it's really interesting how digitization and AI can change things in a way that you didn't even plan when you start doing what you did or what you built.
Absolutely. Like you can upload that image and say, okay, make my smile this, that, and kind of look and see what's possible. Yeah.
Exactly. And this is a growing industry. One of our companies that we work together in the same incubator is doing something similar for aesthetics, for plastic surgery. So starting to build these abilities in medical 3D and imaging and AI, start to build and expand the capabilities, the future looking, the prediction, and so on. So I worked for Invisalign for 6 years. The company became very big and very, very successful. And I decided it was time for me to move on,
Okay.
do the next big thing.
Yeah.
And it was interesting, I worked for Invisalign, and Invisalign motto is saving smiles, helping people smile
Yeah.
more, which is beautiful. It's beautiful. So I decided, just taking that as an inspiration, I decided I want to do something that will save lives. I wanted to
Wow.
do more, more.
More than
And I
smiles.
decided to stay
Actual
in the
save lives.
more than smiles. So I decided to stay in the medical device world,
Okay.
which is my expertise. But also, if you start your own thing, you really have to believe that you're doing something important, because
Absolutely.
it's a roller coaster. Everybody knows that starting a startup is not easy. It has a lot of challenges. There's a lot of difficulties that you have to handle. So believing that what I do matter and will
Yes.
impact a lot of people's lives is something that helps when things are hard.
Oh my
When you
gosh,
have
1,000%.
COVID,
Yes.
when you have wars, when
Yes.
you have stuff that are not so easy for a startup founder, believing in what you do, that it's more than, the ROI of the process, the impact on people's lives, that's what matters.
Absolutely. So how did you think of this idea?
So I was brainstorming. I started talking to clinicians.
Mm.
I went to conferences, and I basically talked to any clinician who was willing to talk to me, and ask them what was their problem, what are they worried about, what they need to be solved. And I was trying to find a problem that on one hand I can solve. I'm an engineer in the end, so I wanted something that
Mm-hmm.
me as an engineer can do something about and understand how to solve. And in the same time, the problem that matters, that important enough clinically and business to create a business around. And my ideas had some transformations and some pivoted but after, I would say, 6 months of meeting people, I met Professor Josh Roder. He's the head of spine in Hadassah Hospital in Jerusalem. And he just came back from HSS, so special surgery in New York, which is considered by many as the top orthopedics hospital in the world.
Mm-hmm.
And me and Josh started to talk, and he basically said, "Can I get Invisalign for spine?"
For the spine.
So for spine, he's a spine surgeon.
Okay.
I would say it's just for orthopedics, but in many ways it's even for any type of surgery that you want. But he, as a spine surgeon, wanted a solution for spine. So he wanted a solution that will bring the ease of use of Invisalign, the optics, the ability to do something small, simple, and efficient into the spine surgery world. And that's how Pathkeeper started. We had some pivot and change and understanding, and you learn as you go. But the basic
For
concept
sure.
was to build something that is radiation free, eliminate the radiation from the surgery room, the same way that Invisalign eliminated some of the radiation from the dentist room, and make it simple and easy to use. If you're thinking business, think about small hospital in Israel or community hospitals in the United States, ambulatory surgery centers. Of that, third world countries hospital, they cannot afford millions of dollars of robots. That's what we wanted to solve. The radiation, the need of a lot of radiation on one hand, and the second one was the cost and complexity of today's solution.
Today's solution, let's just explain to our viewers, prior to your technology, today's solution, maybe you can just explain how that works first and then how your solution changes things.
Right. So without going into too much details, robotic surgery, in a way, you need to create a map of the patient body, specifically the anatomy that you want to work with, for the robot, or for the system, of the guidance system, to be more exact. The common way to do that today is by taking a 3D X-ray in the surgery room. So we bring a big X-ray machine and create a 3D scan of the patient anatomy. That is equivalent to a few hundreds of X-rays.
Wow, that's
And sometimes
crazy.
they need to do it a few times during a surgery, maybe three
So you're
times, four
talking
times during a
about a
surgery.
lot of radiation in order to create that 3D image that the robotics would need to perform
Right.
the surgery. Okay.
Yeah, and if you can argue, and some people would argue that, when a 70-year-old person goes into spinal surgery, it's not that terrible, but if you think about scoliosis surgery, which is usually young women,
Yes.
15-year-old, 18-year-old young women, that's terrible. Having 1,000
That
x-ray in their
much
abdomen.
radiation. Oish,
So
yes.
the ability to eliminate X-ray or the X-ray in the surgery room and the ability to eliminate the 3D X-ray in the surgery room from especially pediatric surgery, we believe it's a huge clinical value for the patient. Without talking about all the other stuff, which is the time, because those X-ray machine takes a lot of time to scan, cost,
Mm-hmm.
those machines are
Mm-hmm.
very expensive, and accuracies, because in the end, our optical system has been proven to be more accurate. We have been able to show to the FDA that we have a very, very accurate system, I believe better than probably most of the systems out there.
Wow. Okay. So just explain then, Erez, how does it work? So instead of having the radiation, what does the patient experience?
So remember we talked Invisalign, we did 3D optical imaging. We do the
Yes.
same here.
Okay.
So instead of taking an X-ray, once the surgeon exposes the patient anatomy, the surgeon can see the bone. They don't see them very well. There's a lot of blood and issues and so on, but you can see a bit of the bone. We
During the
take a high
surgery.
resolution during the surgery. We take a high
Okay.
resolution 3D picture of the bones themselves and use that as our anatomical landmarks. And we
So this
guide the
is the
surgeon.
difference here that it's the radiation that you're referring to was prior to the surgery to map out the 3D image. Is now what you're saying it's during the surgery that this image is taken then?
No, no. What we
Okay.
are changing is from X-ray to optics.
Got it.
So we track the position of the anatomy using a camera. Basically,
Okay.
it's a 3D camera, high
It's a
resolution
camera.
and unique
No
design, but in
X-ray
the end,
vision needed. Yeah.
no X-ray vision. I don't know how much we want to go into the technical details, but basically, the idea is that we look at the anatomical landmark. Little stuff. Think about a map or something. If you know where something specific is, if you know where a certain tree might be, you know where you are in your city.
Yeah.
You can recognize specific landmarks and use them to know where other places are in the map that you imagine. So it's the same thing with surgery. You don't need to see the whole bone. We can't see the whole bone without X-ray. But because we have few anatomical landmarks, because we know specifically some elements and they're very specific, the computer can recognize them in very, very high accuracy, we can complete the map because we know where the other things must be, because it's a bone and it's a rigid body. And once you have a few points, you can basically know where the other points are in space. And now, because it's optics, it means that we can take a 3D picture every time we want in a second instead of bring a big X-ray machine. So everything is
Mm.
radiation free, is more accurate, is faster, and because we can do things again and again and again, we can start building additional clinical capabilities that does not exist today.
Wow, amazing. So, from the surgeon's perspective, what are they finding in terms of the outcomes for them and the benefits for them?
Right. So there's a lot of things. First of all, they don't need to wear a lead vest, which is like few
Wow.
kilograms of lead, and that's
That's
great.
huge, by the way, for surgeons that are standing in surgery for many hours to not have to wear that. Yeah.
Right. So lead vest is significant. And there is something called reference area anxiety, or I would say there could be movement during the surgery that the robotic will not be aware of. So there is some level of anxiety of movement that happens that the robot cannot compensate for. And you don't know if it will happen in your surgery or not. Because we have this 3D camera, we can compensate for that. So we are removing some of the anxiety and some of the
Wow.
risks that are involved in using complex robotic surgery. And we save time, we save money for the hospital, which is always nice.
Wow. Are the surgeries faster themselves or is it
So the
the
surgery themselves is not
pre-op?
faster, but the process of taking the scans is eliminated. So if you look at
Mm.
all the surgery process, then we eliminate some time. Yes. So the surgery, the full time that you are in the surgery room, the full time that the patient is under anesthesia is shorter.
Wow. So is this only being used right now for orthopedic surgery?
So it's only been being used now for spine.
For spine specific.
The medical
Yes.
world, yeah, the
Okay.
medical world is very specific. What works for
Yes.
as an engineer, I can tell you it's very easy to move it from spine to
I was
knees.
going to say you should for sure can apply this to other surgeries as well. Yes.
Yes, but thinking both clinically wise and commercial wise, this requires some additional level of resources. You have to
Mm,
develop the little things, the workflows, the software, the tools.
yes.
You have to
Yes.
bring that to the FDA. You have to create sales team that it's not the same surgeons that buy spine and orthopedics, might be the same hospital, the same department, but not the same guys. So it requires some sort of additional commercial and engineering focus, work, and we want to focus. We want to be successful in spine, significant in spine, and then we get exposed.
So my understanding is that you are FDA approved,
Yes,
correct?
correct.
So what was that process like?
So, I mean, it was a lot of work, there's no doubt about that. There's a lot of quality management that you have to improve and make sure it works. There's a lot of details that you have to get right. But I think so. The preparation was long, cost a lot of money, and took a lot of time. But once we were there, and once we started the work with the FDA, I think the work with the FDA was relatively easy
Hmm.
and open and honest. I really, I don't know, maybe enjoyed those too much, but I was really appreciative of the FDA team, their response, the way that the communication worked, and the proficiency, the level of expertise by the FDA team. So I was really impressed, and it was a very good process. I mean, I believe that the feedback that we got, that the requirement for them to improve our testing and our proof, all of them make sense. When there were some things that we needed to explain, they understood and they understood the limitation that comes even from the business.
Right.
So I think they were very fair and very professional and very good to work with.
That's amazing. So now where is your technology available? Which hospitals are utilizing it now?
Right. So in Israel, we have two systems in Hadassah, one in Ein Kerem and one in Har Hatzafim.
Okay.
And in the United States, we have several installations. And we have signed several commercial deals recently.
How's that?
One with High Ridge Medical, which is one of the top spinal companies in the United States, and they are starting to sell us basically our commercial partner in the United States. And we have signed and we received an innovation award from Vizient, which is the
Wow.
biggest GPO, group purchasing organization in the United States. So a lot of the purchasing processes in the United States is led by those GPOs, those big companies that manage processes and contracts in the US. They have reviewed us, both companies have reviewed us for a long time, I would say, did a very big due diligence, labs, cadaver labs,
Yes.
watching surgeries. And finally, after many months of testing, we got, I would say, approved by both groups. And
Amazing.
they are our tool, not just commercial, but they're a tool to scale because it's very hard to sell in the United States if you don't have strong partners and
Yes.
strong commercial
Absolutely.
partners. And that's basically what
Absolutely.
Pathkeeper has. We have the big GPO that gives us access to thousands of hospitals and a strong commercial, well-known partner and brand, High Ridge Medical. Together, that creates a significant scale opportunity for us to grow in spine and later expand to other clinical indications.
That's really unbelievable. So how have you found it's been for you running this? Because it sounds like you're really at a pivotal point of focusing on distribution now, right? You're past the
Yes,
FDA,
commercial growth.
right? So
Yes.
how have you found the war has affected your plans at all in that
What
area?
war? What war? Look, I mean, this definitely doesn't make things easy. I mean, we are like any other Israeli company, we take the laptop to the mamad,
Yep,
we have an alarm, we run, we come back, and we continue to work. That's our
yep,
life.
that's our life.
And when 7 October happened, and there was this, motto that the Israeli high tech keep moving, right? There's
Yeah,
nothing gonna stop us.
nothing is going to
So
stop
there's
us.
nothing gonna stop us. Nothing gonna stop us now. Um, we keep working. The team in Israel, they work either from office or work from home, and we're going to be successful no matter what.
I love it. I love it. And are most of your team members based here in Israel, or do you also have a team in the US?
So we have a small commercial team in the United States. We have Ryan, who is our chief commercial officer, very experienced spine sales and management, and he leads our US operation. And our chairman, Dr. Richard Westmark, is a neurosurgeon, Harvard trained, and that helps us with the commercial outreach as well through his relationship and experience both as a surgeon and as a businessman.
But all of the actual technology and hardware is all being, and software is all being produced here in Israel.
So we have a subsidiary in North Macedonia. So the development is done both in Israel and in North Macedonia.
Okay, wow, incredible, Erez. Well, this is so fascinating. I really only wish you the most hatzlacha as possible in order to really help both patients. I mean, especially the young pediatric patients and female patients with the radiation is such a critical component to solve in this world. And I love how, as an Israeli, Air Force, ex-Air Force, how you're bringing all this incredible technology, not just to Israel, but to the world. So thank you so much, Erez, for joining. Really appreciate it. And I will put your contact information in the details here for anyone that would like to reach out to you to learn a little bit more about what you're doing. Thank you, Erez.
Thank you, Shira. Have a good day, great day. Bye-bye.